Greetings, my name is Ryan Nix. I'm a partner solutions architect with Amazon Web Services. I'm based out of the US, I'm South African, and my customer base is global. So my interesting challenge is looking at industry trends across the globe, and I've noticed some fairly interesting observations when looking at customers in the US, customers in EMEA, and now customers in the APAC region. The bulk of the customers that I work with are large-scale enterprise. They are Fortune 500 companies, legacy technical debt footprints. They are all going through some sort of modernization journey, and for each one of them, modernization means a potentially different thing. They are all in a transition from on-premises onto AWS. So what I want to have a look at today is a couple of pieces of that modernization journey. What are some of the things that were important to these customers? So let's jump right into it. When I engaged with customers all around the world, there was a consistent theme that came out from these customers. There was a degree of agility that was required. Everybody turned around and said, yes, we're typically a slow-moving, traditional enterprise customer. We would have a software package or a feature that we want to get into the market. We'll develop it. It goes through a very long-winded development cycle, test cycle, security cycle, into production. And typically that would take months. So idea to into production, months. If I combined that with the underlying infrastructure side of things, I had customers telling me, yes, we can scale to a degree, but that scaling depended on how much infrastructure I had available to me. I could provision new VMs, for example. I could grow my empire, but at some point in time, I would hit the boundaries of what I had in terms of physical capability, which got me into a procurement cycle. And when I spoke to customers in that space, they told me it could take us up to 16 weeks to procure a new server. And I was like, that's insane. Let's see if we can change this up a little bit. On the other side of the spectrum, I had sort of net new startup companies coming in with feedback from a customer. And that feedback would come in from like an application, for example, something like an Airbnb app. Customer would say, I'm unhappy about this, here's my feedback, I want to see this as a new feature. And a startup would take that feedback from a customer, put it in the hands of their developers, they would build a new service or a new feature, iterate on the development cycle, test it, run it through securities, and get it into production, customer consuming that new feature in 5 days. And I'm like, there's a disconnect here. So every single enterprise customer is coming up back to me and saying, we want a greater agility. We want to be able to get those ideas built and into production sooner. So shortening the time to production, and I do want to emphasize, these customers are not saying, I want to speed up my development cycle. I don't want to just do better development. I want to get it from development all the way through all of the stages that are important to me into the hands of my customer. It's really focusing on enabling the customer here. The other thing is that process of building out those solutions. My development teams that I spoke to wanted to be able to build a little thing, test it, validate it, and if there was a mistake or if they had done something different, they wanted to be able to fail fast. They wanted to be able to experiment with something, see what works, see what doesn't, and very quickly collapse back if needed to be. So they wanted a low-risk environment where they could experiment, whether that was within the development cycle itself or whether it was on the infrastructure side. So a lot of flexibility, a lot of agility in terms of experimentation. And then finally, continuously improving on things. I'm not going to build the pristine service today for tomorrow. I'm going to build something today, and customers are going to give me feedback, and I'm going to want to change, I'm going to want to iterate on that. I might get something quick and nasty into the environment so that my customers can start using it, and then gradually add more and more features to that environment, continuously evolving it. And that is the modern day sort of modernization trend over there. So combining that with the infrastructure side of things, from AWS, so most of my customers are transitioning from on-premises onto the cloud in the form of Amazon Web Services. And there are a couple of drivers around that. Wanted to get away from some of the on-premise stereotypical data center costs, so that CapEx, that OpEx investment. They wanted the ability to have a an environment that they could spin up very quickly and spin down based on demand. They wanted to pay for things as and when they were using them. They also wanted to take advantage not just of cloud as a basic compute or networking offering, but they wanted to take advantage of native cloud services. Why must I manage my own database? Why must I back up my own database? Why must I worry about scaling things when I can take a native AWS service, something like RDS as a relational database system, and have Amazon do all of the dirty work for me? I want to focus on consuming the database. I want my apps to talk to the database. I don't want to manage that. So that was one element. The other thing was the operational resilience of systems. I can build a resilient data center. Many of my customers have. But it's difficult. It's a significant infrastructure investment. And if you're trying to reach a global audience, you're building resilient data centers in the locations where your customers are. Many of my customers have come back to me and said, we're tired of doing this. We want to get close to our customer, and I want a highly resilient platform that doesn't see me sinking huge sums of investment into building and maintaining my own environments. Other customers said, I can build a resilient platform, but I can't get it to the same resilience as what I'm seeing with AWS within that cost footprint. Right, so a couple of those drivers. I went a step further and I spoke to airline industries, financial institutions, public sector, insurance companies, Air Force, military, Navy. I spoke to customers within the cruise line industry. And a couple of consistent things came back from those customers. Every single one of them said, we want to move faster, we want greater agility. Every single one of them said, we're in a hybrid use case, but I want something over and above being able to run workloads on-premises and in the cloud. I want to be able to do that with a unified experience. I want my developers, my operations teams to have the exact same process, the exact same mindset, the exact same tooling experience, whether they are building or deploying or managing applications on-premises or on the cloud. That's an interesting use case. The next thing they said to me is, we have a technical skill set. We as a customer know that we're able to take third-party solutions, open source solutions, AWS native services, and build out a very compelling DevOps modernized application platform. But if I do that, I have to build out a container repository, a source code repository, a build process, a pipeline, an orchestration layer, a monitoring layer, a security platform. And I don't want to invest my engineering teams, my time, my effort, my money into doing this. I want to focus on what's important to my business. I want to build applications that are meaningful to my customers. So what these customers said to us is, we want something that is a turnkey solution out of the box that they can get up and running quickly and does everything for them so that they can focus on their customers, their applications. And finally, security is important. Very much so in an AWS context. It's very important to us as AWS, and it's very important to our customers. But what our customers were asking for is not just the ability to have something that's secure. They wanted a very prescriptive, guided approach to security. And the step away from, I need security, to how do I actually implement security, and how do I turn a secure platform into not a sort of gate mechanism, but something that's going to guide my developers through what is a best practice process. And when we unpacked these requirements, it became clear that OpenShift was a phenomenal platform to meet these requirements, whether you were running it on-premises or whether you were running it on top of AWS. Right. So we went a step further and we had an analyst company sort of collect data. We did a cross-section of, again, a very broad spectrum of customers in different industries, and some interesting data points came back to us. Using OpenShift on AWS, the customers that we spoke to and that we collected data from sort of came back to us through a survey format and said 66% increase in the time that developers take to get a product from idea into production. Not a variant of the application. We're talking about from concept to production, 66% faster. That's a little bit more agile than I've seen in a stereotypical enterprise context. The next thing was the number of resources needed to do that. A 35% reduction in resources. That's the developers themselves, that's also the operations teams involved. When we spoke to companies like Cathay Pacific, for example, I asked them, how many people do you have running your operations side? They turned around and said to me, 5 people. And then they backed it and they said, sorry, clarification. That's 5 people doing the operations of our entire global OpenShift implementation, and those 5 people are also doing infrastructure, cloud, and. So a significant reduction in the number of hands that are needed to get these workloads done. What this ultimately translates to is, I'm saving money, I'm saving effort everywhere. I can get my projects into market quicker, which means my customers consume those products faster, and if I'm getting a revenue stream from those products, that revenue stream lands in my business sooner. If I am able to get products out the door quicker, I can shift my development efforts onto new projects faster. I may have more time to upskill my development teams. If you look at organizational change, where are we seeing people being recruited and joining companies as new staff? They're going to where the most innovative tools are. They're going to where they can experiment and play. And certainly customers came to me and said, if my developers can build an application quicker, my developers can play and experiment and expose themselves to new technologies, not only improving them as developers, but also attracting new talent to the business. And then, of course, the cost saving that. Because I have less time building these solutions out, I'm paying contractors less, I'm paying development teams. So overall, a significant benefit in terms of these spaces. So let's unpack this. I did say that many of my customers are not interested in building out solutions. They want a turnkey offering. So let's unpack OpenShift very, very quickly. And I think most of you in the room have seen some variant of this slide. It's a container runtime, a little bit of Docker in the background. It is Kubernetes as a orchestration layer. And in that space, it compares to a lot of things in the market. What it does have over and above that is built-in build and pipeline process, so you've got your full CI/CD stack in there as well. You've got a container image repository. You've got a compelling monitoring solution that now in OpenShift 4 has become even more attractive with the likes of Prometheus and Grafana and that coming out of the box. You've got a comprehensive operator model. You've got a service broker API sort of integration in the environment. You've got storage. You've got a service mesh component coming in with the new OpenShift version 4. All of this out of the box, meaning a customer doesn't have to build these things out themselves. That is incredibly attractive, especially if you want a sort of end-to-end experience for your developer operator journey. Taking that and putting it on top of AWS, you now have an increased availability footprint, not just of AWS in itself, not just in terms of the availability zones that you'd be running your sort of compute EC2 virtualization instances in, but also in terms of the native AWS services. You look at a relational database as RDS. It's backed up by the AWS service team. It's scaled by the AWS service team. It is managed for you, which means my customer doesn't have to worry about those. If I look at DynamoDB as a NoSQL implementation, again, the same thing. It scales. It has the ability to auto-recover. It has people in the background doing all of the dirty work for you. If I look at queuing, messaging, and caching layers of application platforms, more and more of my customers are taking applications from on-premise, moving them onto the AWS cloud, using OpenShift as part of that journey, and then modernizing the app further, not just modernizing from a monolith to a container, but then taking another step of modernization, saying, I'm going to replace some of those components of that application in favor of native AWS services. Right. Which brought an interesting question from one of my customers. One of my customers was a fairly well-entrenched OpenShift customer transitioning to AWS, and this customer came up to me and said, we know OpenShift, our container workloads are in OpenShift, we can stand it up in AWS, we can move from on-premises onto the cloud, but we want to start taking advantage of these native services. And the concern they had was, do my developers, my operations teams suddenly have to go through a ramp-up process, learning semantics about a new environment? Do they have to learn a completely new tool set, a new interface? Do my developers have to swap hats, for example, and step outside of OpenShift into a totally different console to stand up a tool that they don't know and then somehow stitch it back to the application that's going to consume it. So we took this request and working with Red Hat, AWS and Red Hat engineering teams built first the AWS Service Broker. It's an open service broker API integration, slots into OpenShift, and gives developers and operations teams the ability to provision native AWS services from within OpenShift. So the developer experience that they are immediately familiar with, the processes they're familiar with, they can stand it up without stepping outside that environment. The next thing is, because of the way OpenShift stores secrets and OpenShift passes information in the background, you could stand up something like a relational database in an AWS account, deploy a containerized front-end application inside OpenShift, and then bind it together without ever leaving the OpenShift platform. And let's have a look at a quick demo of that. If we can just cut across to my other system here. Right, and I had got smited by the demo gods, so this is a recording of something I did a little bit earlier on. But as you can see, this is inside OpenShift. You can see that the service broker has been integrated, so it's exposing those native services within the platform. A developer can simply go and select one of those services. In this case, it's an SQS queuing mechanism. Parameterized features, so we've taken best practices and been very prescriptive in this context. They can fill in very, very minimal information, or a developer or operator can go and change those settings according to what's meaningful to them. Click on OK. What that does is the OpenShift environment sends that as an instruction to the broker. The broker in the background launches an infrastructure as code template. My developer does not need to step out into an AWS console. I'm just showing you that so you can see what's going on in the background. But what happens in the background is that service then reflects in OpenShift as something that's being provisioned. It's not ready yet. It's an out-of-band process. After a little while, if you continue refreshing the page, it will eventually come back and say that process has completed and it's ready for consumption. In the meantime, we're going to build out a very insipid little sample app in the front, deploy that via OpenShift as a containerized workload. Bearing in mind, we're just doing a queuing mechanism in the back, front-end application that's going to talk to it. No correlation between the two. So once this is deployed, create a route, depending which part of the world we're in. And let's try and connect to that. I'm expecting this to fail. Right, and you can see there it's coming back with some missing parameters. So what needs to happen is we do need to create a binding. We're going to take all of the building blocks that are required to consume that AWS service. So the endpoint, usernames, passwords, ARNs, IAM credentials. We package them up in CloudFormation in the background, pass it to the broker. Broker then stores that information inside the secrets in OpenShift. And what my developer can do is simply go and create a binding linking these two things together. And what's nice about this is it provides a means for developers to consume these services without actually having to know the usernames and passwords themselves. It's simply environment variables in the app consuming what's going on in the background. Let's have a look if we do a refresh here. Create the binding, go into that binding, and link it to my application. Yes, this is done graphically. Nothing stopping my developers from doing this from a code perspective or a command line, so you can build it into your pipelining process as well, and you can completely automate it. There you can see OpenShift detecting a change to the application, rolling out a new version of it with the newly populated environment variables. And if we do a refresh over there, we get a successful sort of API interaction. That's a little bit boring, and if you're an enterprise customer, building little APIs is not what you're doing. What you're probably doing is working with something that's consuming a database. So let's have a look at a similar thing regarding a relational database. I think this was MySQL. For those of you who've worked with AWS before, standing up an RDS instance, you'd have to know It's multi-AZ, so it's going to deploy that database environment across more than one data center. So when you're doing this, you're going to have to worry about option groups, parameter groups, the VPC I'm deploying it in, which subnets, when's my backup, when is my maintenance window, what is my major and minor version updates. There's a lot of settings, knobs, and dials that a developer would need to wrap their head around. So what we've done is we've taken those settings and provided a prescriptive process to them, but again, giving developers the ability to override those settings, or an operations and security team to assess these settings, change them to what's relevant to the business, and utilize completely customized templates in the background. And as you can see over here, one or two changes. In this case, I added in the AWS VPC that I'm deploying into. I changed the CIDR that's allowing incoming connections. And there my database is being provisioned out of band. Now that'll take about 15, 20 minutes. So what I did do is I cut this video presentation short there. But the journey is very similar. Wait for that database to provision. Once it's ready, deploy my front-end app, do a binding, and consume it. And I do want to call out, aside from me stepping into the AWS console here to show what's going on in the background, at no point in time did a developer leave the comfort and familiarity of OpenShift in itself. And they're touching an AWS entity in the background. What we did do from a security perspective is take the IAM role that service broker utilizes. The broker has the ability to stand up resources in the AWS account, not the developer. What the developer has is a ability to log into OpenShift. We're using OpenShift's native role-based access control to state whether that development team has access to the broker and which services they can stand up within that broker. But it's not a case of the developer can bypass that system and actually interact with the AWS account directly and run away with expenses over there. Let's kick back to the previous presentation. All right, so one aspect where we're seeing AWS customers working with OpenShift and actually getting best of both worlds, but through a very unified experience. OpenShift historically was a very developer-centric system. Quite recently, I'd say OpenShift 3.11 going into 4, a lot of focus moving towards the administrative side of things or the operational side of the platform. So we're seeing a whole collection of new interfaces, consoles, to give operations teams more visibility into what's going on in the environment. So whether that is an overall cluster perspective, whether you want to drill down into a node within that cluster, or whether you want to go even further down and look at what's going on from a pod or an application point of view, we have a significant increase in operational visibility. And for a lot of my customers, this was something that they were asking for, whether it was from a compliance perspective or not. Again, controlled by role-based access control. So if I had certain operations teams that needed to see certain business units, I could do that. If I had different degrees of operational interaction, I, for example, could have monitoring and auditing entities in the company only needing read access control over certain screens. I can do that. The new OpenShift security role-based access control model gives me that degree of granularity. And again, drilling down not just to which interfaces you can see, but also providing which projects or namespaces are available for that. Likewise, we needed to be able to track logging and events with a bit more detail. And this potentially could be quite noisy. So what we did is we created a cluster-wide event stream. An operations person now can go and see events and logging for the entire cluster at a very high level, or they can drill into a physical node within that cluster and see what's going on, the events in that space. And if they're interested, they can drill down even further and see the events per pod or per application. So very big focus on what do you as an operations person want to see, what is meaningful to you, and how do I get to that interface. Coming back to the requirement around a prescriptive security platform, OpenShift has always had a fantastic security model. Things like taking a container off of a public repository and running it, and OpenShift sort of stopping that container and saying, hang on, that container's running as a root workload, do you really want that? has now been extended even further, where we now got a context-specific constraint where my operations teams can sort of lock down and put policies in play, guiding development teams around, what are the kinds of workloads that they can run within OpenShift. Further than that, pod-level security policies. I can say per pod, what sort of controls, what mechanisms do I want to enforce to drive my corporate security policies over here. Something coming back to the typical cloud customer. Many of the customers I'm working with had started an AWS journey. They were familiar with scaling mechanisms on the cloud, the ability for things to dynamically detect a change in demand, scale up more compute capability, and scale that down and pay for that scaling mechanism. And when it came to OpenShift of old, this was a bit more manual and clunky. So what some teams are doing is manually provisioning and scaling out the EC2 instances in OpenShift. And once they had done that, then Kubernetes layer within OpenShift would then overlay the applications. We wanted something a little bit more dynamic, so we worked in terms of building out the Kubernetes Autoscaler. It's now built into OpenShift as a standard. Inside OpenShift, you can configure what are your minimum, your maximum thresholds. You can define what your monitoring metric is, and literally have OpenShift spin up your underlying infrastructure. And once that infrastructure becomes available, OpenShift then balances your application workloads across that. If something fails, auto-healing kicks in, terminates the underlying host, spins up a replacement, and OpenShift then detects, oh, there's a new node. Let me move my my application pods onto that new platform. Right. For customers who wanted a more managed experience, we worked with Red Hat in terms of a managed offering on AWS in the form of OpenShift Dedicated. One of the big changes there is we had customers coming to us from a compliance perspective saying, I need visibility into the account. It's not good enough that it's running in somebody else's account. I need to be able to say to auditors, I know what's going on. So what we did is we brought a bring your own cloud or a cloud choice offering into the picture. Customers can now say, I want a managed version of OpenShift, managed by Red Hat, but running in my AWS account. So you take your AWS account, you reach out to the Red Hat account team, and the Red Hat SRE team literally go and provision OpenShift into your AWS account, run it for you, but you've got all visibility into it. You can take advantage of cost control mechanisms such as reserved instances and such. And then finally, with the shift into the operator framework, we're seeing a lot of desire around operators. So firstly, joint partners of AWS and Red Hat, the likes of monitoring companies, Splunk, Dynatrace, security companies in the form of Twistlock, for example, taking a lot of their software integrations that were meaningful to OpenShift customers as well as AWS customers, and using the operator as a means of simplifying that journey for their customers. Some fantastic stuff coming through in not only Operator Hub, but also internally inside the Operator Hub in OpenShift in itself. What we've also done is we've started a journey around building an AWS service operator. Very similar concept to the service broker. Only difference now is it's driven through an operator. So for customers that want a more native Kubernetes experience around provisioning those AWS resources and consuming them, they can do that as well. Right. And then I've got a customer that came to me and said, it's great, fantastic, OpenShift, AWS together. I don't want to do that myself. I want somebody to guide me through that modernization process. I want somebody to help me stand up those environments. I want somebody to help me do that migration process. I want somebody to really guide me through the DevOps CI/CD process. I want somebody to be a cultural mindset change ambassador within my organization. That's probably the most difficult thing for all of us to change. And that's when we started reaching out to the partners in the space. And let me just wrap my head around this. AC3, a joint partner of AWS and Red Hat, has actually come very, very nicely into this picture. They're providing a full spectrum, whether it is migrations, whether it is organizational change management, whether it is modernization of applications from monoliths to containers, whether it is a DevOps journey. They're doing that for all of the customers. Take some time, have a look at the service broker, the service operator. They are both open source projects. So that being said, you can make them your own. You can provide meaningful feedback to us, whether they are doing what they need to do within your businesses. And enjoy the journey. OpenShift and AWS together are a fantastic combination, and I hope they'll change your business. Thank you all for attending here.